Hello friends, welcome to my channel. And today we're going to look at this problem from Codility training lessons. So a non-empty array A consisting of n integers is given. Array A represents numbers on a tape. So any integer p such that p is in this interval between 0 and n exclusive. So p splits the tape into two non-empty parts. So this is the first part and this is the second part. The distance between two parts is the value of the sum of the the absolute value of the sum of the first part subtract the sum of the second part. Okay, and then so we want to write a function that given a non-empty array of n integers, we want to return the minimum difference that can be achieved. Okay, so in that example, the minimum distance that can be achieved is 1. So the function should return 1 as explained above. Okay, so it looks like we can use the prefix sum to do that. Okay, so we're going to use prefix sum to solve this problem. Okay. So we are going to return a minimum value. So let's first create a variable result, and we assign it the largest value. So in integer max value. Okay. I'm going to return the result like so. And the next we are going to compute for the prefix sum. Okay, so prefix sums would be, okay, so this would be an array. The length of the array would be the same as the length of given array A. And so the first element of prefix sum would be equal to the first element of A. And then we're going to calculate for the prefix sum starting with second position, because the first position is the value for the first position is already assigned. So I is less than, I think we can use prefix sum length increase by 1, and then we're going to assign or calculate the value at position I of prefix sum. So that should equal to the value of current A plus the previous prefix sum. So if current position is I, then the previous position must be I minus 1. Okay. And then so that is calculating prefix sum, and then we are going to calculate for the difference. Okay, so minimum difference. So write another for loop. So we got to use p to denote for that. Okay, so p0. Okay, so let's look at the example here. We have 5 elements and we have 4 p's, right? Looks like for the first one, we're looking at the first element, and also so that is the first element. that is the sum of the rest of the elements. So this will be the sum of the first two elements, and that is the sum of the rest of the elements, right? Okay. So we are so if we have length 5, then we want to look at to divide the array into split in 4 places, right? So if we denote p as 0, then we are looking at the range or maximum value of p to be at prefix sum length should be minus 2. Okay. Minus 2. Okay. So take this as an example. So if p is 0, then so if the first p is 0, then the last p must be 3. And then if the length of a is 5, then the last p must be 5 minus 2, which is 3, right? So we want p to go from 0 to prefix sums length minus 2. Okay. I plus plus, we increase I, and we are p, now I. Okay, so we're ready to calculate for the sum. Right? Okay, so I'm going to use the left part to denote for the left sum, to denote for the sum of the left parts, which is going to be prefix sum in p. Okay. And so right sum. Right sum is going to be the prefix. So here the prefix sum, the largest one in this example must be 13. So it's 13, yeah, which is the last element of the prefix sum. So we want to, so this is how we calculate right sum, which is going to be the last element of prefix sum minus left sum. Okay, and then we can calculate result, right? Result should be the minimum of the difference between left and right. Well, the absolute minimum, so ABS, I have left sum minus the right sum. That's it. So let's run the code. Okay, so we passed the example test cases. So the time complexity, so we have one for loop, it's going through all the elements from A. So let's say that if we define n equals to a dot length, okay, it's the number of elements of A, then this for loop will be big O of n, right? And then this for loop will be another, so it's going from 0 to length minus 2, which is just big O of n, because it's not significant by only having 2 fewer positions. So this is also going to be big O of n. Okay, so we don't have any other loops. So the time complexity for this algorithm is linear. So T of n equals to big O of n. Okay, so let's submit. Okay, 100%. Well, thanks very much for watching. Hope you guys have a nice day. Bye bye.